So you can still use the process that we used on the last lesson. So if you want to plug in values to graph your points, you can do that. Today I'm going to show you how to use each of the parts of your transformation in order to graph it from the parent function as well. So again, our parent function here, or our standard form for exponential, is a times b to the x minus h plus k power. Okay, again, where h is your horizontal transformation or translation. Okay, so that h value will move it left or right depending upon if it's positive or negative. You also have a vertical translation, that's your k value. Okay, k is on the end of your equation, so that adding of that value or subtracting of that value will move it up or down. And then the last one, a, is your orientation and shape. So if that a value out front is negative, it will reflect it in the x-axis. If your a value is greater than 1, so say it's 2 or 3 or 4, something like that, it stretches your graph out vertically, so it makes everything further away from each other. It stretches it out vertically. If a is between 0 and 1, so it's a fraction, okay, like 1/2 or 1/3, something like that, it compresses all your points. So it makes them closer together. It pushes them towards that x-axis. So we are going to use those to graph our functions today and state the domain and range. So our first problem here, we have y equals negative 1/2 times 5 raised to the x minus 2 power. Okay, so we do have an a value here. Okay, our a value is this negative 1/2. Okay, I'm going to highlight it the same color I highlighted a. We also have an h value in our equation. Okay, and that is this 2 right here. Okay, so our a value, negative 1/2. Okay, since it is negative, that means it is reflected in the x-axis. Okay, it's also a fraction, so it's 1/2. That means it is between 0 and 1, so it will be compressed vertically as well. Okay, then an h value, h is right here. Okay, our h value is going to be positive 2, not negative 2. Okay, so our h value is positive 2, not negative 2. Okay, that means we're going to move right 2 units. Okay, so we're going to take all of our points, we're going to move them right 2 units. And then our k value, there's nothing added or subtracted afterwards, so our k value is going to be 0. Okay, so this is not translated vertically. All right, so our parent function in this problem right here, in this first example, is 5 to the x. Okay, so that is our parent function. Okay, so 5 to the x power is our parent function. So I'm going to graph that with a dashed line so we just know where that parent function is. Okay, so if I plot, put negative 1 in for x here, that'd be 1/5. Plug in 0, it's 1. Plug in 1, that is 5. Okay, so just a light sketch of where my parent function would be. Okay, and that's my dashed line there. Okay, it's not the graph of what we're trying to find. This is just the parent function. That's why I did it lightly. Now our actual graph, we need to take those points, we need to reflect it in the x-axis, compress it vertically, and move it right 2 units. Okay, so reflect your point in the x-axis, so now it's down here. That 1/5 is now here. You need to compress it vertically, so you need to multiply it by half. So this 1/5 is going to get closer to the x-axis. And I know that's hard to see, but then we also have to move it right 2 units. Okay, so this point then will move 1, 2 to the right. Okay, so my new point is going to be over here. It'll be easier once I do a non-fraction point. So if I move on to my parent function at that point 1, okay, we need to first reflect it in the x-axis. So if I'm here, it's now here. Okay, then compress it vertically by 1/2. So multiply it by 1/2. Where would it be? If I multiply -1 by 1/2, what do I get? -1/2. -1 times 1/2 is -1/2. Okay, so it's at -1/2. And then move it right 2 units. 1, 2. It's right here. Okay, now this point 5 right here, again, reflected in the x-axis. So now it'll be at -5. That's right here. Okay, you multiply it by 1/2. 5 times 1/2. So 5 divided by 2 is 2.5. So that would be here. And then I need to move that right 2 units. Okay, so those are my new coordinates. And then I can connect them. Okay, you can see that it was reflected. It's now shrunk down because we compressed it, so we multiplied each point by 1/2, and then we moved it right 2 units. Like I said, I'm showing you a different way to do it. You can still plug points in for x and get the y coordinate. Your domain, we can still plug in any value for x and it will give us a y coordinate, so it is all real numbers. Your range, so those are your y values on your graph. Okay, we would have y such that y, where are all of our y values on this graph? If I go with my graph here, where are all my y values? They're all negative, right? So that means they have to be what? Less than 0. Okay, so my y values are all going to be less than 0. Okay, so another example, example 2. Okay, so for this one, we don't have an a value. However, we do have an h value. What's our h value? If I look at my equation here, what's my h value?
Let's see, 3.
Not 3.
Wow,
-3. Okay, so since our h value is -3, we are going to move left 3 units. And this time we do have a k value. Okay, what's our k value? -5. So this one will go down 5 units. Now if you don't have an a value, like here we don't, your a value is just going to be 1. Okay, your a value is not 0. Your a value is 1. Because if you were to multiply that by 0, everything would be 0. All right, so our parent function for this one is 2 to the x. Okay, so our parent function is 2 to the x power. So here, if I were to plot that parent function, plug in -1 for x, I would get 1/2. Okay, so I would go -1, 1/2. If I plug in 0, I get 1. And if I plug in 1, I get 2. And if I plug in 2, I get 4. Okay, so this is where your parent function is. Okay, and we need to move each of those points left 3 and down, left 3 and down 5. So take that point at -1, 1/2. Move it left 3 units. So 1, 2, 3. And then take that point and move it down 5 units. 1, 2, 3, 4, 5. And make that point. Okay, then we'll go to the point 0, 1. Move that point left 3 units. So 1, 2, 3. And then down 5. 1, 2, 3, 4, 5. Okay, then our point 1, 2. Left 3. So 1, 2, 3. And then down 5. 1, 2, 3, 4, 5. Our last one here that I plotted was at 2, 4. Okay, so take that point, move it left 3, 1, 2, 3, and then down 5, 1, 2, 3, 4, 5. Okay, so now it needs to make this same basic shape that I had in the parent function when I connect my new points here. Okay, so that would be my actual graph using those points after I moved them. So then my domain, okay, your domain, again, you can plug in any value for x. So it is all real numbers. Okay, then my y's for my range. If I follow my x-axis, they stop at this line right here. That's at -1, 2, 3, 4, 5. So that's at -5. So that means my y values have to be greater than -5. Okay, so all my y values have to be greater than -5. It does approach -5, but it never actually crosses that line. That's your asymptote. Okay, questions on example 2. So again, I just plotted the parent function and then moved it according to what I had written down here. Okay, then one more. This one is a decimal for your a value. Okay, so our a value is 0.1, which is 1/10. Okay, so 1/10 if you were to write that as a fraction. Okay, that means since it is between 0 and 1, it is going to compress it vertically. Okay, so I need to take that point and I need to multiply it by 0.1 to see how it would be compressed vertically. Our h value, do we have an h value in this problem?
No, we do not.
No, you don't. So that is going to be 0. So your h and k can be 0. Your a value is never 0. Okay? H and k can be 0. So this one's not going to be translated left or right. Okay, then our k value here is going to be -3. So that means we are going to move down 3 units. So with our parent function, first we need to multiply that y value by 0.1, and then we can move it down 3 units after that. So our parent function would be what in this one? What's our parent function? How was I figuring that out before? If our parent function here is 2 to the x power, right? What is our parent function here? 6 to the x power. Okay, I'm just going to do the 3 points. So if I plug in -1 for x in our parent function, what do I get? 1/6. Okay, if I plug in 0 for x, what do I get? 1. And if I plug in 1 for x, you get 6. Okay, so this is your parent function. And I need to take those 3 points. First, we want to compress them vertically, and then we want to move them down 3 units. So my first point here was 1/6. I need to take that 1/6, so 1 divided by 6 is about 0.16 repeating, so 0.167. You need to multiply that by your a value. So I need to multiply it by 0.1. Okay, that's 0.01 and then 67. Okay, so that's really close to this x-axis here. And then what we want to do is move that point down 3 units. So I'm talking about this point here. I first multiplied it by 0.1, so that gets it very close to the x-axis. Then I need to move that point down 3 units. So go 1, 2, 3. That's that new point right there. Okay, I want to do the same thing with 1. Okay, this 1 value from my parent function, I'm going to multiply by 0.1. So if I multiply 1 and 0.1, you get 0.1. Okay, then I need to take that value and move it down 3 units. So 1, 2, 3. Okay, my last point here is 6. I need to take 6 and multiply it by 0.1. You get 0.6, so that's about right here. Okay, then I need to take that point and move it down 3 units. 1, 2, 3. You see how it kind of compresses it? Your points get closer together. Okay, so our shape then will take this form here. Kind of like that. It's exponential, so it has to curve up more. All right, so what's our domain for this exponential function? What's the domain? Thank you. Okay, then what's the range? Your y values have to be what? Where's your asymptote at?
So it's less than, or y is greater than, I don't know.
It has to be greater than because your exponential function is going up. Okay, if it's going down, it has to be less than. Since it's going up, it has to be greater than. Greater than -3. Because your asymptote is at -3. Now again, you can just plug in points into your function. Okay, so if you take your calculator and you say, I want to plug in -1 for x here. Just take 0.1 times 6 to the -1st power minus 3. You'll get your point, and you can plot that point. Okay, that still works. I just want you to be able to identify what each of these values are as well as you go through that. Does that make sense?